Northern India Engineering College, New Delhi. He did his BE in Punjab Engineering College, Chandigarh in 1971, his MTech and PhD from IIT Delhi. Then he served for 6 years in Bharat Electronics Limited, Ghaziabad, and there he designed and developed mechanical structure of Indira radar. He has served in various capacities in different universities abroad for more than 15 years. Dr. Goville's specialization is conversion of diesel engine into 100% biogas engines. He has also developed a conversion kit for converting diesel engines to 100% biogas engines as well as dual fuel engines. The engines, the 100% biogas engines designed by him, they have been exported to various countries including UK, Korea and Nepal. So I think it's our privilege that we have a person like Dr. Govil to deliver the topic on utilization of gaseous fuels. So
Right, sir.
okay, thank you. Him having a vast experience, practical experience in this field, I'm sure his lecture will be very fruitful for all of us. Dr. Govil, please.
Good morning to all of you, and good morning to the persons who are sitting in the center. I don't know how many centers are connected, but I think 4-5 centers are there. Good morning to all of you. Well, today my topic is utilization of gaseous fuels in stationary and automobile engines. This topic has been chosen because you know that we need power for electricity, power for automotive use, and I'll add another dimension, though they are station engines, but to the mobile towers. So everywhere there is a requirement of power actually, and once we require the power, then definitely we are depending upon the fossil fuels. And as you know, the fossil fuels are fast depleting. Nobody knows how much is the life, but definitely we are having problems with the fossil fuels. They are getting depleted. So we have to find out an alternative actually. And alternative could be what we have studied, and all these things are that if we have these gaseous fuel engines introduced, that will help a lot because fossil fuels are depleting and then emissions are quite high actually. I'll show you a slide where if you are having a diesel engine or a gaseous engine, what is the difference in the emissions actually. In Delhi itself, there are millions of cars are there, millions of vehicles are there, and like that, But the emissions which are coming out, it is horrible, literally horrible actually, and a day may be there when it will be very difficult to breathe actually. So for that to take care, we must switch over to the gaseous fuels to be utilized in IC engines. Another thing is in station diesel engines also, if you look at then how much power is required for per person per family, maybe a 1 kilowatt 2 kilowatt power is required. For agriculture purpose, maybe 5 kilowatt 10 kilowatt for a short wire is required. But definitely we are all the time depending upon the grid actually. My focus over here will be to tell you that if we keep on depending on the grid power, we cannot get it. So centralized power generation system is not useful. We should go to the decentralized power generation system actually, based on our need actually. India is having a lot many diesel engines in the agriculture sector and otherwise. Diesel is being subsidized, but we must find out ways and means what best can be used. In this regard, I would like to say that if we use natural gas as a substitute, it will be very helpful. I'll go a step further. This natural gas is also not available everywhere. Another solution is bio CNG. What does it mean is biogas we can generate. Biogas we can generate from the organic waste. I'll show you the slides. And once we are having this biogas as the fuel generated, it can be purified. Then it can be compressed. It can be filled into the cylinders and can be utilized for automobile purpose or any other purpose actually. Other gas is producer gas that can be utilized. So we must shift more to your natural gas. Of course, natural gas is linked with the fossil fuels. It comes from the substrate of the earth and all these things. It's related with that. But subsequent to that, that's not available everywhere. So we must go a step further. We must go to the bio CNG or producer gas for our utilization. First of all, let us come to this utilization of gas engines, because we are having spark ignition engines and compression ignition engines. In the spark ignition engine, we can use it in the bi-fuel mode. What does it mean is that you are having a gas cylinder also, you are having a petrol tank also, because any gas engine should have a ignition mechanism actually. The gas has a high octane number, it is a high ignition temperature, it cannot burn of its own, hence you need a ignition mechanism, okay, to start the ignition actually. In the petrol engine, already you know that there is a suction, then there is a compression, then there is a spark, and then there is a exhaust. Everybody knows it. So for that reason, once we are having this, so we can convert our spark ignition engine into bi-fuel mode. That is, you are having a petrol tank as well as you are having a gas cylinder. As and when there is maybe a need, you can switch over one from another one. It is independent. You should not be confused that both are going. No, it's not that. So once suction is there, so if it is working in the petrol, then from the carburetor, the petrol, or from injection mechanism, the petrol gets mixed into the air, goes inside the engine and then burns. This is one way. Second one is that once air is being sucked in, then you must have your gas is being mixed from the gas carburetor. So there is a gas carburetor, air fuel gas is being mixed, and once air fuel gas is being mixed, it goes to the combustion chamber, and then compression is there, and then a spark is being produced. So that is what is a biofuel. Second one is dedicated CNG engine actually. So the engine which works only on CNG, because in the CNG is compressed natural gas. Let me tell you, there is first of all natural gas, methane content. We are having CNG compressed natural gas. What does it mean is, because the gas has to be compressed to a pressure of 200 bars to be filled into the cylinders. The cylinders presently available are 6 kg cylinder, 12 kg cylinder, 18 kg cylinder, which you must have seen. So in those cylinders, the gas is being filled up to 200 bar, and the cylinders are being tested for 250 bars, and once the gas is being compressed, filled into it, then you will have a larger volume, or you can say you have increased your mass. Under 1 atmosphere condition, I'll tell you, I can give you the readings for that. It doesn't work well, but once you compress it, at least you can go. Say a bus where the 18 kg cylinder is there, so roughly 10 kilometers goes in 1 meter cube of the gas actually. In 1 kg or 1 meter cube, density is almost similar, slightly this CNG is lighter. Okay, so for that reason it is being 180 kilometers or 200 kilometers you can cover, 10 kilometers per meter cube, like that. That's a average. So you can have dedicated CNG engine where only gas will be there. So this is what is a spark ignition. Second is compression ignition engine. Compression ignition engine, as all you know, that air is being sucked in, air is being compressed, only air is being sucked in, only air is being compressed, and then diesel is being injected, where this makes a heterogeneous mixture. So there will be the diffusive burning over there, and hence we will have your power, and from there we can run our station engines or our. In case of dual fuel engine, what is the meaning of dual fuel? Dual fuel means two fuels. So first of all, in the suction itself, we will have air plus gas coming into it. And as I told you that gas has a high ignition temperature, it cannot burn of its own, hence you need some mechanism to burn it. So diesel is being utilized as a pilot fuel. So a small amount of diesel, okay, say in the 30% or 20% range, in that range, it acts as a pilot. So when this is being injected into the combustion chamber, okay, so there will be first two types of, one is called diffusive burning, another is homogeneous burning. In the diesel engine having this dual fuel mode, first the diesel will ignite wherever it will find the air, and then that burning will further burn the fuel inside, and in the dual fuel you will have diffusive burning as well as your homogeneous burning. Next is converted diesel engine to operate on 100% natural gas. Any diesel engine, as you know, we are having a Kirloskar diesel engine, we have Tata and all these things, engines are there. They are 4-stroke water cooled or air cooled engines are there. Then this is can be converted to a 100% gas engines. What does it mean is that once we are having a gas mechanism, then we have to do certain changes in that. The main changes are, first of all, we need a gas carburetor. Like a petrol carburetor gives a 1:14.5 ratio, approximately 15. Similarly, depending on the gas, if it is a natural gas, if it is a biogas, if it is a producer gas, so every gas has a air fuel ratio actually. So gas carburetor will give the air in that correct air fuel ratio. So we need a gas mixing device, that is a, once this gas is being there, then you need a ignition mechanism. In this, what we do is that in place of your diesel pump, we convert it to the ignition mechanism. We put a distributor over there, I'll show you. And once we are putting a distributor over there, and in place of diesel injectors, we put the spark plugs. We tap the holes, tapping is being done, and seeing the suitable availability of the spark plugs, because as you know, we are having a 10mm spark plug, we are having a 12mm spark plug, we are having a 14, 18, like that. There are variety of spark plugs which are available in the market, because the spark plugs which are being utilized in your in your vehicle, scooters or your motorcycles or your cars, they are of that range actually. So that is being fixed. So first the holes are being tapped, and there you can put it. Okay. So they are the two things. And third thing is your governing mechanism. In the stationary diesel engines, we have to have a governing mechanism, because the charge air plus gas is to be controlled. That has to be in proper proportion. So what we do is that we take the pickup from the flywheel. Flywheel we put a sensor, and then from the sensor it will sense the speed, and once the speed is being sensed, then it will give the signals to the actuator, which will control the butterfly of the gas carburetor. So these are the how we can utilize it. So questions वगैरह तो अभी last. Now, there are the certain fuels you can utilize your gases. That is, you can utilize LPG. LPG is a mixture of propane and butane, and all these gases can be utilized in the dual fuel mode as well as in the 100% mode, in the spark ignition or as well as in the compression ignition. Any of it can be used. Petrol, diesel, calorific value is given, and you can see once the natural gas is there or biogas is there, they are having a high ignition temperature, so they cannot burn off its own. And hence they require ignition mechanism. In the dual fuel mode it will be with the diesel injection, or in the spark ignition mode it will be with the spark actually. And these are the air fuel ratios which are being given actually. These are some compressed natural gas fuel characteristics is there, where you can see auto ignition is there. Boiling point is minus 162 degrees centigrade. Air fuel ratio is 17.24. It is on a weight basis. Volume base is different and the weight base is different. Then fuel air mixture quality, it mixes very well. Pollution is very less. Carbon monoxide, hydrocarbons, NOx. Depends, of course, as you know, the NOx is a phenomena of a temperature dependent actually. So we have to see accordingly how the variation of NOx is there. And combustion ability with air is very good actually, between 4 to 14%. If the air is available, then immediately it will start burning. Natural gas is safer than gasoline. How come? Ignition temperature is higher than gasoline and diesel. It is lighter than air and hence diffuses very fast. LPG does not diffuse into a system very fast. What happens is, in the LPG, it gets stored into the pockets. Suppose in the kitchen and other places, just is there, and there is LPG leak, then it will be stored in the corners, and whenever you start burning, it will burn actually. But with natural gas, it can diffuse easily into the air actually. Diesel and gasoline will pool on the ground, increasing danger for fire actually. Once diesel or petrol spills on the ground, then it can catch fire and create a problem. CNG or NG doesn't do like that one. It is non-toxic and will not contaminate groundwater if spilled actually. While the petrol or diesel, as you know, whether it is seaside or otherwise, it will do that. It is cleaner fuel as far as emissions are concerned and environmentally clean alternative. It is available, as I told you, it is available in the fossil fuel form also. Otherwise, from the biogas is a content, methane content 60-40 plus hydrogen sulfide and other things are there. But if it is purified, it is as good as natural gas actually. Which can be purified. It can be purified to 98% also. So it is as good as natural gas. Environmentally compatibility is there. It can be used in converted diesel and petrol engines, and low cost of running. The cost of running is low, that's why people are getting converted their vehicles to the gaseous mode. It is attractive because cheaper than gasoline, low air pollution, lower greenhouse gas, and large quantity of fuel available actually. but definitely there are certain disadvantages also. The vehicle range. You can fill the cylinders and can run to a certain miles. Of course, same is true with the petrol also, but for the petrol, it is available in every state and all the petrol pumps, or diesel is available, which is not the case of your natural gas. But sooner you will find a day when biogas purified, converted, making them bio-CNG should be available. In foreign countries, it is there. I hope soon it will be seen in India also. Fuel storage. Because the gas is being compressed to 200 bar pressure, you need cylinders for that, makes the vehicle heavy, and there is a problem actually. Then infrastructure cost and sufficient supply, because as we are having a petrol pump, so should we have the CNG pumps also. In Delhi it is there, or maybe somewhere other places also. So for that you need to make a infrastructure. Then on-board storage due to low energy volume ratio. Okay. It knocks at high loads. There is a knocking. We have to take care for that actually. And carbon monoxide at higher load levels in the natural gas. So they are the certain disadvantages. Otherwise, it's a cleaner fuel. It is a cheaper fuel. It is easily maneuverable. Absolutely no problems. This is just a table for showing you what is the emission levels. Suppose you are having a diesel, so you can see carbon monoxide 0.20 grams per kilometer, hydrocarbon 0.4, NOx 9.73 in diesel, carbon dioxide 1053, and particulate matter 0.10. If you have a natural gas, then definitely CO is slightly higher, 0.4, hydrocarbons are there, but NOx level is lower than diesel. Similarly, carbon dioxide is lower. Biogas, it is still lower, 0.08, hydrocarbon 0.35, then NOx 5.44, carbon dioxide 223. There are some typical figures taken for the certain data. It can vary slightly, but not much. It is indicative. Then we are having wet biomass. We are having biomass. Could be two: wet biomass and dry biomass. Wet biomass, we can get biogas. That is methane 60%, carbon dioxide 40%, hydrogen sulfide and other traces are there. Any organic material like your cow dung, human excreta, your food waste, your industrial waste, any of these, they can be converted to biogas actually. The plants are there, the technique is there, technology is there, and then that biogas can be purified, can be compressed, fill into the cylinders, can be used to automobile industry as well as to the stationery industry. We are having a dry biomass, that is, we are having gasifiers. We can produce producer gas actually, which is giving carbon monoxide and hydrogen of the order of 18%, 20% like that. So that is also possible from the wood, from the coal, from any of the materials, sticks and other things we can produce, and all these gases can be utilized for your running the engines either of these modes. This is a biogas plant. Here the cow dung or other waste, food waste, other things can be put to the system. This is called the fixed dome. In the fixed dome there is a well, there is a partition wall, the waste is being fed and they are mixed with a proper proportion of water actually. Okay. Then it has a cycle time, retention time is there, and once you keep on feeding it, then there will be process. Under that process, the biogas will be produced actually, and that mass will become lighter and will fall to the other side of the wall actually. And once it is falling to other side, then after that it will be coming out from the outlet of the chamber, and this biogas is stored over here. It can be utilized. We are having approximately just 980 million tons of cattle dung. We can produce 63.8 billion cubic meter of biogas. We are having around 250 million of cattle tank. We are having around 6 lakh villages. So from that, once we are having these animals, we can have such a large quantity of biogas. And if this biogas is produced, processed, then there cannot be any shortage. This is just a table where I just shown that from municipal solid waste, from municipal liquid waste, from distillery, from press mud, from food and fruit processing waste, willow dust, dairies, paper and pulp industry, tannery, we can have such a large quantity of input which can be processed and can be converted to biogas. It is just a table which will tell you how much we do, because we must know how much waste we are having, how much we can convert. So from the cattle dung, I have written 40 liters. What does it mean is 25 kg of the cow dung. If I tell you otherwise in the terms of meter cube, 25 kg of the cow dung can give you 1 meter cube of the gas in 24 hours, provided you maintain a temperature inside the chamber, and this temperature best is 38 degrees centigrade, because this is in thermophilic and mesophilic region actually, and in this case we can convert 25 kg to the 1 meter cube of the gas. Similarly, from the green waste, food waste around 12.5 kg to 15 kg can convert to 1 meter cube of the gas. Bamboo dust is there, fruit waste is there, bagasse, the waste of cane sugar, dry leaves, non-edible oils, oil seed cakes, the jatropha. From the jatropha we take out the biodiesel. I hope you know it. And that waste can be utilized for generation of biogas. So for that we can do that. This is biogas production process, where carbohydrates, fats, proteins, there is a hydrolysis process that is then converted to sugars, fatty acids, amino acids, acidogens. That is, first there is a process of hydrolysis. It is mixed with, as I told you, that the raw material is to be mixed with the water. Once it is being mixed with the water, then hydrolysis is there, then the acids are being formed, then there is a carbonic acid and hydrogen carbon dioxide and ammonia is being formed, acidogenesis process, and after that is methogen process. So these are the 4 processes under which the biogas is being produced. So first is the hydrolysis, then acid is being formed, then acidogenesis is there, and methogenic is there. Now I come to, once we are having the biogas, what are the different processes by which it can be purified? First one is absorption into liquid, then adsorption on solid surface, membrane separation, cryogenic separation, and chemical conversion. Absorption process is the same as you all drink Coca-Cola. There, once you open it, then there's a gas. That's nothing but carbon dioxide gas. It means the water get dissolved in carbon dioxide. In the same way, I'll just show you that in this process, the water and gas, biogas, at higher pressure, approximately 10 bar pressure. The gas is being compressed to 10 bar pressure. Then the water is being pressurized to 10 bar pressure. So gas is passed from the bottom. The water is being fed to the top, and hence once there is a intermixing over there in the tower, and you can get the purified biogas to extent of 95%. Methane, which is coming 60%, biogas which is coming approximately 55 to 60%, and when it is coming out, it is of the order of 95%. Another method is adsorption process. Adsorb. The zeolites are being used. So methane and carbon dioxide. There is this on the zeolite under pressure, 7 bar to 10 bar pressure. Once the gas is being compressed and passed through the towers, then methane, carbon dioxide will be adsorbed onto the surface. Adsorbed, not absorbed, adsorbed on the surface. Methane is being released actually. So there are two towers which I'll show you, and once these two towers are there, then one works for 5 minutes, then second works, they work in tandem, and then there is release of methane. It's get collected because other side is there's low pressure, immediately the gas is being there, so you can have the purification, you can have methane. The other processes are costly. Membrane separation is there, cryogenic is there, and chemical conversions are there. They are a bit costly, but membranes are available from where it is being passed, and you will get a purified this one. Cryogenic is reducing the temperature. Okay, so you will have to apply the energy to make it a cryogenic system, which will still be costly, and the chemical conversion. This is just in detail. PSS pressure swing adsorption system, which I just explained to you. It is economical with a high purity. Capital costs are moderate. Relatively quick installation and startup. Not much scalability in production. Equipped maintenance on the higher side. Chemical regeneration is required. This zeolite, after 5 years of the service, it is being changed actually. So once it is being done, it can be regenerated or it is changed. Second one is water scrubbing. As I told you, simple process. Remove both hydrogen sulfide and carbon dioxide using a water stream. Water at higher pressure, gas at higher pressure, both are being interacted, and you will get the pure gas. High pressure, difficulty in recovery of carbon dioxide, because carbon dioxide when it mixes with the water makes carbonic acid. Either it could be, if you want to recycle the water, you have to purify it again. It will be a costly affair, or else it is just let to the ground. It will again a source of pollution only. So we have to see it accordingly. Cryogenics is there, very high purity is there, but capital cost is very high. Requirement of large sites, longer startups and shutdown process there. Limited scalability is there. Membrane also, the rolls are coming from which it is being passed. Fast installation is there. The startup is good. Production of output is flexible. Purity and flow rate can vary, but it's not viable. It's really very costly. And chemical absorption. The chemical absorbents are more efficient in low pressure. Regeneration of the solvent requires a relatively high energy input. Disposal of byproduct formed due to chemical reaction in the problem, and again the chemical is to be regenerated, again a costly affair. This is the method which has been shown how, in this case, from the biogas digester we use a single stage compressor to compress to 10 bar pressure. Then the gas is being stored in the vessel. Then water tank, we have a pump then we have a flow meter, and then we are having a biogas scrubber. Once from the biogas scrubber, the dissolved carbon dioxide and water goes out, gas is being stored in the pressure vessel, then there is a moisture filter is there, then pressure reducer is there, then we are having a 3-stage compressor which can increase the pressure to 200 bars, and then it is being filled into the gas cylinders actually, which can be further utilized with your vehicles. This is a system for purification. If you see number 1, okay, it is the gas is being produced, then water is being compressed, gas is being compressed, stored, water is being compressed, and the gas is the tower which you see in the center over here. So the gas is being put from the bottom, while the water is getting sprinkled from the top, and here there is a material, okay, which is being put to give the more interaction time of the gas as well as the water. Once the gas is being purified, then it is being taken to the cylinders over here. There is a cleaner, the moisture is being removed, and you will find on the right side number 19, which is a compressor, okay. So this compresses to the 200 bar pressure, and then it is being filled to the cylinders as required. You can see the towers as I discussed. The height is around more than 4 meters height is there, okay. So there is a middle section, the top section and the bottom section. The gas is being fed from the bottom, water is being sprinkled, and we can get the gas. And we are having here, there are ceramic materials which are being put, which can give you more interaction with gases. Just to tell you, if you increase the pressure of the gas, then more dissolution of water and carbon dioxide. More carbon dioxide will be dissolved when increase the pressure. If you can see at pressure 1 bar at 0 degree centigrade, say it is 0.40, okay. But as the temperature will increase, the solubility will decrease actually. So if you increase the pressure, more soluble is there, but if you increase the temperature, it is going to decrease. This is what is the PSS system. In this, there are 2 towers are there. The raw biogas is coming into one at a pressure of 7 to 10 bars. Inside the cylinders, there is a zeolite material, zeolite 13. It is an alumina oxalate material. So it is having a small pores. The carbon dioxide will be absorbed into the surface actually, while methane will pass from the top. It has a timer mechanism, automatic timer mechanism. So 5 minutes one cylinder will work. So at that time the methane will be let out, carbon dioxide will be absorbed onto the zeolite material. After that, in the second cylinder, the raw biogas will pass, the methane will be let out, carbon dioxide will be released. Meanwhile, when the methane is there, carbon dioxide being absorbed, at that time from the first cylinder the carbon dioxide is being released actually, and hence after another one, this will work. After 5 minutes one cylinder, then another cylinder, then again the first cylinder, and like that, and finally you will get the methane. Here one advantage is there, then you can store the carbon dioxide also, and once you are storing this carbon dioxide, you can make it as dry ice. Equipments are available, where you can form the dry ice and which can be utilized for many purposes. As you know, once we are taking the food to the aircraft, we use the dry ice and all these things. So for that, it can be utilized. It is a hot cake. It sells like anything. At IIT Delhi, with Dr. In the CRD department, Dr. V.K. Vijay, they have compressed this and filled into this one, and they are running the vehicle there. Otherwise, also if you see in Delhi, we are running the CNG buses. So what I'm saying is, either you can have the natural gas from the fossil fuels, or you can have the biogas converted to CNG and used to the vehicles. Actually, there isn't any difference. Perfectly, no problems. The cylinder, same cylinders we are utilizing and using it. This for the producer gas. This is a downdraft gasifier where there is a hopper, the drying zone, the pyrolysis zone, the combustion zone. So under controlled combustion, you get a producer gas, which has a percentage of carbon monoxide and hydrogen. That can also be utilized either in 100% mode or it can be used otherwise. In Second World War, there are many vehicles, 80,000 vehicles which are moving in Sweden. They had this type of mechanism for running the vehicle on producer gas. But as you know, liquid fuel is easy to carry for a longer distance. That's why it is not being preferred, and there are reasons, but otherwise this can be utilized. There is a derating of the engines. What is the meaning of derating? Is a diesel engine or the petrol engine, they have certain output, certain kilowatts, but once we are using these gases, the power is not so. Why it is so is because first is the lower calorific value of the gas. If you see my table, first one, second table, where you can see the biogas is 18,000 to 20,000. Producer gas is 4,000 to 5,000 kilojoules per meter cube. Vis-a-vis, if you take diesel, it is 42,000 to 45,000. If you take methane gas, of the order of 50,000. So definitely there is a difference in calorific value, hence power out. Another reason is that once you are sucking the air as well as gas in the suction mode, the gas will replace the air actually. And once gas is replacing the air, hence amount of air which is going to the combustion chamber is less. Hence there will be derating. So we have to see how much. It comes out to be 30 to 40% derating of the engine is there. So there
it will not work, mix with the air.
It will mix with the air, but it will replace the air. There are two things, Suppose there is 100 cc of air is coming. Now if you are mixing the gas in that ratio, isn't it? So once the gas is coming, engine will take 100 cc only, isn't it? And once that is taking 100 cc, if you are putting the gas now to the cylinder, it is 85% air and 50% gas, So air has been replaced or not? So there will be derating of the power actually. Is that clear? This is the diagram where engine has been converted to 100% gas engine. It could be biogas, it could be producer gas, it could be natural gas. Okay, so what has been done is, this is presently a diesel engine has been converted. So you can see that there is a spark plug has been put. A spark plug has been put in place of injector. Sufficient space is available and it can be managed. Otherwise heads are available, okay, to adapt them to spark plug mode actually. Second is electronic ignition mechanism. So what we do is, on the camshaft there is a crankshaft and the camshaft. So where we are putting the distributor, at that place, where we are putting the pump, diesel pump, at that place we can put our distributor. Actually, mechanisms are available, it can be put. Third is gas carburetor. The gas carburetor is the one which is a combination of a venturi and a butterfly. So once the air is being sucked in the venturi, the gas pipe is being given, you can see, and once the gas pipe is there, okay, it will give the correct amount. The mixing, the design should be, venturi should be such that it gives the air field ratio in the correct proportion. And then there is a butterfly which will control the charge which is going to the engine actually. Now this butterfly is being controlled by the governing mechanism, which in my second half I'll show you what are the things, equipments which are available, where you can convert a diesel engine or a petrol engine to a 100%. In this case, on the flywheel, we put a sensor, a speed sensor. It will sense the speed. Once the speed is going low, once you put the load, the speed will reduce. Once the speed will reduce, at that time you need more charge. It means butterfly should open actually. So there is a governing control mechanism is there, where the speed will be sensed. It will control the butterfly, open the throttle. When the speed is low, as the load is low, at that time the speed will increase. It means butterfly should be closed, or should be, opening should be reduced. So for that reason, immediately what will happen is it will act on the throttle and will control it. They are the. Another thing is diaphragm operated valves actually. This gas to be controlled. So the gas is being controlled by a vacuum mechanism. When the air is being sucked in the manifold, there is a low pressure. That low pressure is being felt by this diaphragm type of valves, which will create a differential of pressures and give you the calculated amount of gas into the system actually. So this is the whole mechanism of conversion. As you see in your vehicles also, those who know about the compressed natural gas which is being used in the buses, or there is a gas kit is available. So from the 200 bar pressure, the gas kit is reducing the pressure first to 60 bars, then to 30 bars, and then to 6 bars, and then to 1 bar, slightly higher than that, This is done into the gas control mechanism. The gas is not being supplied into the 200 bar into the engine. No, it is not. It is being supplied at the same, slightly higher than atmospheric condition, or just at the atmospheric condition. So there has to be mechanism, and those are operated in this fashion. This is
साइड में कर लीजिए प्लीज बॉटम. Thank you.
This is a gas injection mechanism. In this, we can feed the gas to the engine in 4 types. So if you see, this is a 6-cylinder engine, where we have put the multi-point injection system is there, or single point injection is there. So if you see the side figure, the photo first is the mixer with carburetion injection. There is a carburetor, air fuel mixture is there, just as I have shown you, there is a venturi over there, and then air and gas mix. So this is the carburetor, first one. Second is the single point injection, that in the manifold you give single point and then it goes to a different cylinders actually. Single point injection system. Then there is a multi-point injection. Every cylinder you give the gas. It is not directly injected. That is another step. But before that, in the manifold itself, you give to the 4 points or 6 points, wherever it is, but it is still in the manifold, it's still just above the valve over there. Lastly, you can directly put the gas into the combustion chamber also. So there are the 4 ways how this gas is being fed into the system actually. If you see this, there are very many ways by which we should run the engine in such a way where there is a minimum emissions is there, maximum power is there. So compressed natural gas engine operated in high volumetric efficiency, because as I told you right now, once the gas is replacing air, it means volumetric efficiency is decreasing. So for that, if you want to increase the volumetric efficiency, then supercharge or turbocharge. If you see the previous figure over here, in the we are having a turbo compressor. In the turbo compressor, the turbine is being run by the exhaust of the engine, and then there is a compressor which will compress to a higher pressure and sends to the inlet manifold of the engine actually. Okay. So you should have, if you want to increase the volumetric efficiency, supercharge or turbocharge, or change the design of the head. If you want high flame speed, then create a mechanism, either the combustion chamber or a mechanism, so that you have a turbulent effect, or you have to change the combustion chamber geometry actually. Once you create a turbulent effect in the system, you will have a better gas air mixing actually. You can have more power out of it. Higher compression ratio, suitable combustion chamber for higher compression ratio. Reason being, compression ratio is directly related to the power actually. So if you have a higher compression ratio, diesel engines have higher compression ratio than the petrol engines. So for that reason, if you want a higher compression ratio, but you must see that it should not knock, because more higher compression ratio, it will start knocking actually. Suitable air fuel ratio, we can have the lean burn operation, we can have injection type, we can have the turbulent effect. We can, if you are having a lean burn operation, then definitely our ignition intensity, ignition mechanism should give higher energy so that it can burn the lean burn. Low emissions, ultra low emission vehicles are there. Then fuel storage system. Right now we are having those cylinders which are heavier. If we can develop, already people have developed with the carbon fiber and all these things, so composite or other material that will make lighter. Once they are making lighter, the vehicle will become lighter, will go for a longer distance. Then engine operating condition, you have to set the ignition timing, you have to see the best torque, then injector timing and intake valve closing timing. So all they are the design parameter which has to be incorporated into the system to make the system best actually. This is a multi-point injection system. From the tank, this is a gas control. As I told you, there is a tank over here. With the tank, there is a pressure reducer. 200 bar pressure has to be brought to 1 atmospheric condition, and there are different compartments are there where it gets reduced. Then it is being properly, with electronic control or manual control, it is being injected into the system. A comparison was made where a diesel engine converted to natural gas engine. So what is there? What is the data which I will show you right now? Okay, that compression ratio was 20.28 in the original one. Then it was changed to 14.5 for natural gas. It means diesel engine was run at 20.28 compression ratio. After that, the diesel engine was run at 14.5 compression ratio, as well as natural gas engine was run at 14.5 compression ratio, and it was compared, because with the speeds, how much speed we must have, how much pressure, how much temperature, like that, okay. So they are the pressure data. So if you see the 1500 rpm in the first graph, the diesel engine, the red is the diesel, the green one is the 14.5, okay, diesel, and the black one is 14.5 natural gas actually, okay. So like that, the comparison has been made from 1500 to 4000 rpm, and a study has been done, okay, that how engine behaves under different rpm conditions for these engines actually. Similarly, the temperatures also, it has been studied, okay. Similarly, what is their indicated torque and other things? So it has been seen that indicated torque was at 2000 rpm was higher, okay, in case of the diesel, but in case of the gas it has reduced it. And reasons are same, which I told you, that there is a volumetric efficiency effect is there, calorific value effect is there, and like that. Similarly, indicated power, okay, the variations are there, and ISFC, fuel consumption, okay, fuel consumption is also decreasing over here, and can be seen, okay. Indicated mean effective pressure is around 7 bars, 7.5 bars in case of the diesel engine, while in case of the gas it is reduced actually. Similarly, carbon monoxide and NOx, okay. So at one equivalence air fuel over air equivalence, we can see that first of all the CO is almost not there, but after that is increasing, while NOx is increasing and then further on decreasing actually. This was as part of natural gas 100%. Now I will tell you that how this biogas or producer gas or natural gas is being utilized in the dual fuel mode actually. As I told you, dual means air plus gas is being sucked in, air plus gas is being compressed, then pilot fuel is being injected, and then power is there, and then exhaust is there. So if you see this diagram, again what we are doing is that first there is a gas carburetor. In the diesel engines you do not find a gas carburetor, just air is directly coming. So but to convert it to a dual fuel mode, we are putting a venturi, a gas carburetor over here, where gas is being passed through this one. Once there is a suction, velocity will increase into the passage, pass through the venturi, pressure differential will be there, and that pressure differential will be utilized to suck in more and more of the gas actually. And the diesel is injected, and injector remains same as it is. So not much changes are required, only you have to put a designed gas carburetor, and that gas carburetor should be controlled, governing should be there, which I will show you in my next slides. We are doing the mechanical governing as well as electronic governing for that. There are certain graphs where it has taken as different load percentage and the diesel actually and the gas. So as you see, the black dots are there, okay, where square log rate, the diesel is increasing as the load is increasing, but in the dual fuel mode, okay, the gas portion is there actually. So there is a utilization of around 70% of the gas and 30% of the diesel. One of the most problem is that we are not changing the injector, we are using the same injector actually, and we must see that if we make larger percentage of gas, say 80%, 85%, 90%, at that time the injector will become hot. And once the injector is hot, because diesel is injector is supplying the diesel is one, and the diesel is cooling the injector also. So we have to take care that we cannot substitute it to a higher degree, else there will be problem with the coking, that is at the tip of the injector. Okay, there will be coking mechanism, the holes may be closed, okay, like that. Similarly, we can see the thermal efficiency. Thermal efficiency is lower vis-a-vis diesel engine, but at the higher load it is comparable. Similarly, if we see the pressures also, these pressures at the 20% load and 80% load, that's what the readings we have taken. So once at the 20% load, the gas will not be burnt actually, the whole gas will not be burnt. Biogas is a slow burning gas. What happens is, lot of the gas will pass through the exhaust, and that's what we call as a late burning actually. That material is prepared but not burning, it will burn in the exhaust actually. So exhaust temperatures are higher of gaseous fuel engines vis-a-vis your liquid fuel engines. Same is carbon monoxide and hydrocarbons. Definitely there is an improvement on your emission levels. This is the heat release diagram. So at 20% load and 80% load, okay, as I told you that in the 20% load or 80% load in the dual fuel mode, first this will be diffusive burn, and then once there is there, then homogeneous burning is there, unlike the petrol or the diesel. In the diesel it is a heterogeneous mixture, and there it is homogeneous mixture, but in this case of dual it will be working for both actually. The cyclic variations at the lower load is quite higher vis-a-vis at the higher load. Higher load, this is more stable than at the lower load conditions. They are the references which I have taken. Okay. Thank you. Thanks a lot.
So when we use the dual mode,
Yes.
in that case the compression ratio.
Exactly.
So in the dual mode, the compression ratio is less.
In the dual mode,
Compression ratio.
no. In the dual fuel, we are not changing the compression ratio.
For changing the compression ratio, we should change the piston also.
Yeah, that I will be telling you in the second half of it. Yeah, I'll tell you what are the different methods to change the compression ratio.
So why we use the diesel engine for dual fuels? Why do petrol engine? It has a spark plug and it has a carburetor. Then why we use diesel engine?
And it has the same compression ratio.
Just one by one. In the petrol engine, the compression ratio is 7 to 10, 7 to 9 like that. In the diesel engine, it is 15 to 20, 23 it goes. In the gaseous fuel engines, you need 10 to 12 only. So, you cannot increase the compression ratio in the petrol engine, but you can decrease the compression ratio in the diesel engine, so that there is a smooth running of the engine. Petrol engine, one compression ratio, diesel engine, another compression ratio, gaseous engine, in between that. Any other question from the center?
Question from the center.
Yeah, please. Yeah. Good morning. May I invite some questions from the centers also? You're most welcome.
Good morning, sir. Hello, sir. I am audible.
There are any questions from the centers? You can please ask.
Sir, my question is
Okay, otherwise we will now break for tea, and after 15 minutes
Yes.
we will again assemble for the second session of this lecture.
But let me ask the centers, did they find it useful?
Yeah, sure.
Hello?
hello.
Riyat and Bara, please.
Yes. Did you?
Sir, this is from Riyadh. Good
Yeah.
morning.
Good morning. Did you find it useful?
Sir, you have shown the diagram conversion of diesel into 100% biogas.
Yeah.
Does it require any changes in the specification of engine also?
Does it require any changes in the specification of the engine for converting diesel to 100% biogas?
Yes, it is required. It is required, which I will cover in the next lecture. We have to change the compression ratio.
Okay, so I think what we can do is after the tea break, when we continue in the second session, then we can have question answer at that.
There is one question.
Yes.
That what will be the change of power when using biofuel and petrol or diesel?
When we use
Biofuel, petrol or diesel.
biofuel, petrol or diesel.
Petrol or diesel. Like what will be the change in the power?
Comparative between
Okay, the power loss is around 30%. 30 to 40% power loss is there, and of course it depends upon what is the percentage of methane content actually. If the methane content is lower, then definitely more is required actually, but this loss is around 30 to 40%. Any other question?
Is there any change in RPM also?
No, RPM you cannot change. We have to maintain the RPM actually, because if you have to generate the power, then engine should have 1500 RPM, isn't it? Because your alternator is connected and it will create that much voltage at 1500 RPM. So for that reason only, we are governing it, because to have the constant RPM actually.
लुधियाने से ये
हाँ जी बताइए.
तो उनका नेम बोल दीजिए.
Hello, Government Polytechnic Oil Ludhiana.
Sir, in dual fuel engines, we can use the furnace oil.
Your question, I think your question is in dual fuel engines. Can we use the furnace oil? That is the question.
Yes, sir.
Okay, that is the question. In dual fuel engines, can we use the furnace oil?
Well, it depends upon the viscosity, because people are trying for that if we maintain heat the oil and put it into the system, it has to be studied. I have not studied that.
Sir, what effect will be on fuel using?
Yes.
Sir, what effect will be on fuel efficiency using biofuel?
Fuel efficiency, it is lower actually. The once we are using the gaseous fuels, then the thermal efficiency is lower than your petrol or diesel.
I think we can answer the question.
Okay. Government Engineering College बीकानेर. आपका माइक म्यूट लगता है मेरे को.
मॉर्निंग सर.
Yes, good morning.
अब आवाज आ रही है आवाज.
Okay. Sir, can we use turbocharger in this engine?
Yeah, turbocharger. I just showed you that turbocharger will utilize to increase the pressure of the gas and give to the system actually.
Okay. So we need not have any modification if we have already a turbocharged engine, diesel engine there. Then it can be used as it is, right?
Yeah, but compression ratio has to be decreased, you know.
Okay.
Yeah, you cannot, because higher the compression ratio, you cannot use it. Means the main factors are the compression ratio, the gas carburetor, and then your ignition mechanism. Okay, they are the three parameters. So we have to see that, you know.
Okay. So we have to modify the compression ratio only.
Yeah, there is a need for that. There is a need.
Okay. Thank you, sir.
Thank you. So, the changes in the specifications that are required, the sir will cover after the tea break. Right. Okay. So 15 minutes we will again assemble. Thank you.
ਉਹ ਲਾਈਵ ਨਹੀਂ ਚਲਾਉਣਾ ਯਾਰ, ਲਾਈਵ ਨਹੀਂ ਚਲਾਉਣਾ, ਕਹਿੰਦਾ ਥੱਲੇ ਲਾਈਵ ਸਟ੍ਰੀਮਿੰਗ ਕੰਮ ਕਰਦਾ। क्या सी है चौका लगा
कहते भी मैं चेयरमैन को लेके आऊंगा इससे करने जा रहा हूं Should I bring chairman at about 1 p.m?
क्यों लंच होना जी?